Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is Matrices and Calculus. The topic we are going to discuss today on the discussion of tutorial question bank, Module 1, Matrices. Before going to discuss that Module 1, here what are the topics which is covered and what is the syllabus, and again under the syllabus what are the subtopics are covered, and again based upon that first we need to discuss that properly, and after that we discuss that clearly regarding the question bank and everything regarding that one by one the terms. See, here this is the Module 1. As we know that while we are going to observing here, the Module 1 is the based on the matrices under the matrices and calculus. Here the topics are covered under this Module 1, that is the rank of a matrix by echelon form and normal form, inverse of non-singular matrices by Gauss-Jordan method, and again other topics are based on the system of linear equations under here, that is solving the system of homogeneous and non-homogeneous equations. These are the topics under the Module 1, that is the matrices and calculus. The first module is the matrices. And before going to discuss here, first of all we need to discuss that here what is the meaning of the rank of a matrix, and in that what are the based on the operations which is involving, and again how to do that, how to find the rank of a matrix by using the operations. That means we need to discuss that first of all, that is elementary operations, and after that elementary operations first we need to discuss the echelon form and again the normal form, the inverse of a non-singular matrices by using the Gauss-Jordan method. And moreover, finding the rank of a matrix, generally the three methods are we are going to discuss here. One is the determinant of a matrix, the echelon form of a matrix, and normal form of a matrix. Based upon these are the three methods we need to find the rank of a matrix. And before that, that is what are the elementary operations. First we need to understand. Here, what are the elementary operations? That means sometimes it is called as a elementary operations. That is elementary operations or elementary transformations. First we need to discuss here under the elementary operations, like under the elementary transformations, basically the two terms, that is the two types. One is elementary row operations and also elementary column operations. First if we discuss that based upon the elementary row operations, and similarly the column operations are also same like this. Here what are the elementary row operations, and based upon that what are the conditions it is satisfied, and again what is the notation terminology like that. First we need to discuss properly. Here the elementary row transformation under here, the first one is that is interchange of any two rows. This is the meaning of one of the elementary row operations, because of we are going to applying only the row operations. We should not applying any column operations. That is under the elementary row operations. That is one is the elementary row operations or elementary row transformations. And again here how to denote it in the notation wise, that is elementary row operation, that is the meaning of interchange of any two rows. Here the interchange of any two rows is nothing but here, for example, based upon the interchange of any two rows or something it is, that is denoted the notation wise, that is Rij. That Rij is nothing but it is sometimes it is a Ri implication like that Rj. That is the meaning of interchange of any two rows. That means while we are going to say something replacing the I is equal to 1 and again j is equal to 2, that is R1 and also R2. For example, it is a R12. That is also nothing but R1, it is interchange, that is a R2. That is the meaning of here, that is interchange of any two rows. Not only here, like any two operations, like R2 interchange R3 or R1 interchange R3, whatever it may be. This is the meaning of interchange of any two rows. That is denoted the notation wise Rij, or according to it is a Ri interchange like that Rj. That is the meaning of according to here interchange of any two rows. And second, what is the condition for the elementary row operation? That means here multiplication of any row by a non-scalar, that is a non-zero, that is a scalar with any value k. That means what is the meaning of here? If we take any something in the non-zero row, we need to applying like multiplication with any non-zero number. That multiplication is a not only like that, it is a like 2 into ri1, and that is indirectly it is 1 by 2 is also nothing but that is a multiplication. That is the meaning of multiplication with any non-zero number, either it is a fraction or something, any like that, positive or negative, whatever it may be. That is the meaning of multiplication of any, that is a any row by a non-zero number. That is a non-scalar, that is a scalar number. And what is the notation wise? The notation wise is nothing but k into ri, and sometimes it is alpha into ri. That is depend upon any value of k, it is any real value or something, any value. That is either the 1 or 2 or something, 1 by 2, minus 1 by 2, whatever it may be. That is a, here it is a k is a any non-zero number. Here that is the meaning of multiplication of that particular linear row which is a non-zero number. That is a k. And again, for example, here in case of according to it is a 2 into that is a r2 like that. Here k is nothing but that is a 2. That is the meaning of here multiplication of any non-zero number. That is here k is a value. That here remember need to understand, sometimes it is alpha any value. And again, what is the other, the row operations? The third one is add a multiple of one row to another row is a condition. That is simple terminology. It is a add a multiple of one row to another row. And what is the notation wise? For example, it is by taking together the r1 and also r2. That is r1 plus 2 r2 like that. That is the meaning of here it is adding a multiple of one row to another row. That is the meaning of third condition. It is under the elementary row operations. And notation wise here it is a ra plus r minus, that is a k into rj. That means addition or subtraction, whatever it may be, of k times the j row 2, that is a ith row. That is the meaning of here consider any, like one of the example is r1 plus 2 into that is r2. Here that is the meaning of I is nothing but 1, and again that j is nothing but that is a 2, and again k is nothing but it is a 2 is a value. And sometimes it is a consider any negative number, that is a minus values, that is a r2 minus that is a 3 into that is r3 also. That is the meaning of here ra plus k into that is a plus or minus k into rj. That is RDA multiple of one row to another corresponding that particular row. These are the three conditions we need to remember under the elementary row operations. That means one is the majorly interchange of any two rows or something, multiplication with any non-zero number, add a multiple of like any one row to another row. And here clearly given the notations are also. And again based upon this one, and again in the column operations are also. Like what are the column operations? For example, the corresponding column transformation are also denoted in price of r, that is a caj, and again alpha into that is a cj, or something c alpha into that is a k into ca, otherwise ca plus or minus k into cj. That means whatever we understood, that something able to understand based upon the row operations, and column operations are also same like this. These are the three different type of the elementary row operations or elementary row transformations, and similarly elementary column operations or column transformations. Based upon these are the, it is called as like elementary operations or notations are also clearly we discuss. And further based upon these elementary row and column operations, and further rank of a matrix. Based upon that, here what is that, how to define the rank of a matrix and what are the methods here, that we need to discuss here. The rank of a matrix under the model 1, this is the starting point to finding the rank of a matrix. That we need to understand the basically first of all, that is a elementary row transformation or elementary column operations. And again here shortly how to define the rank of a matrix. That means here according to the definition point of view, we need to discuss like the two definitions we can define. One is shortly and second one is briefly. And how to define that shortly, that means within the single statement how to define that, that is a rank of a matrix. And what is that denoted or what is the notation wise also we need to discuss here. Here the rank of a matrix in the shortly, it is the largest order of any non-vanishing minor of a matrix. This is the simple within the single statement, that is the definition of the rank of a matrix. It is the largest order of any non-vanishing minor of the matrix. And here we need to understand that one by one the terminology. Here it is the largest order. That means any greatest or maximum or it is highest like that. Largest అంటే ఏదన్నా తీసుకుంటే మనం maximum తీసుకోవడానికి possibilities order అనేది in the given any particular matrix. And here non vanishing. Non-vanishing means it is a not equal to 0. Vanishes means it is equal to 0. Non-vanishes means that is a not equal to 0. And again, minor. Minor is nothing but the particular value that is a determinant. And here, based upon this statement, what it is here, any given matrix in that, we need to identify what is the maximum like that. The particular maximum, the data is not equal to 0, it is equal to satisfied. And if it is satisfied, that type of the condition is called as a rank of a matrix. This is the within the single statement, the definition of the rank of a matrix. That means it is the largest order of any non-vanishing member of a matrix. And in other terminology, how to define the rank? In other terminology, it is a order of the highest order non-zero determinant of the matrix. It is the order of the highest order non-zero determinant of the matrix. While we are going to observing the first one and second one, both are the same within the single statement, that is the definition of the rank. Here, largest order, that means it is the highest order. That both are the synonyms. That is the largest order or maximum order. And again, it is a non-vanishing. That means it is a not equal to 0. That is a not equal to 0. For which one? It is a determinant. That is nothing but indirectly it is a minor. That is nothing but it is a determinant. It is also in other terminology we can define that is a rank of a matrix. It is the largest order of any non-vanishing member of the matrix. If you understanding the first statement, second is also both are same. In that particularly given any matrix, here we need to take that what is the maximum order, the particular that is not equal to 0 if it is satisfied, that is the rank of the matrix. And in other terminology, how to define that? In other terminology also within the shortly, how to define the rank of a matrix? It is a maximum number of linearly independent of a matrix. It is a maximum number of linearly independent of a matrix, or it is a rows or columns of a matrix. And what is the meaning of this? Same. It is the largest order, highest order, maximum number. And linearly independent, that is nothing but determinant, that is nothing but it is a minor. And it is a rows or columns. You can take any rows or columns in the given matrix. Therefore, it is also particularly based upon the first statement, second statement, and the third statement. All are the equal, indirectly or directly. It is we define the rank of a matrix within the shortly. That means within the single statement we can define these are the three different type of the rank of a matrix. We can define that. And next one, and it is denoted by or something. Okay, before going to discuss that, denoted in briefly. How to define the briefly the rank of a matrix? That means whatever it is given the shortly, that is within the single statement, but it is a briefly. That means here not a within a single statement. We need to give that something more. One more, it is a statement added. That means if it is given that clearly that is definition, we can define that is a rank of a matrix in the briefly. Then how to define? That we need to observe here. It is a non-negative integer R is said to be the rank of a matrix A. That means if you are saying the rank, it is a non-negative, that is a non-negative, it is a like that, it is a not equal, like any not other than the positive is not like that, it is a non-negative. That means it is a positive indirectly. If the rank is said to be rank of a matrix, if it is possess the following properties, that means following the proper conditions. Here, what are the conditions to require to satisfy the rank of a matrix? Here, there is at least one minor of an order R which is not equal to 0. That means whatever we are going to take the matrix, that is a minor of the order, at least one R is which is not equal to 0. That means if you are saying something, the rank is that is not equal to 0. For example, the given matrix is a 3 by 3. For example, the 2 by 2 is not equal to 0. That means that is the meaning of here conditions. If it is saying the rank is a R, that it is a minor, at least one minor R is that is not equal to 0. Then what is that? That is the rank of a matrix. And based upon the second statement, every minor of an order R greater than R is 0. That means based upon it is what is the meaning of this one? For example, the given matrix is for example 3 by 3. For example, the matrix is a 3 by 3. And in that matrix is, for example, the data of that is a 2 by 2. is not equal to 0, then it is a maximum. For example, it is the data of the 2 by 2 that is not equal to 0. And again, moreover, the data of that 3 by 3 is equal to 0. That means if the matrix is the order is a 3 by 3, the data of the 2 by 2 is not equal to 0 and data of the 3 by 3 is equal to 0. That means based upon this one, here it is the rank of a matrix is it is equal to 2. Because of if you are saying any particular matrix R is a rank, then automatically R plus 1 that is equal to automatically it is a 0. For example, the data of the matrix is, for example, the matrix is a 4 by 4. And in this, the data of that is a 3 by 3 is not equal to 0. And the data of 4 by 4 it is equal to 0. That means here it is a whatever it is a maximum that it is not equal to 0, that is rank of a matrix is 3. And 3 plus 1 order that is equal to 0. Therefore, that 4 by 4 is that is equal to 0 means it is not a rank is a 4 condition. That is the meaning of here briefly. Here if it is saying the rank of a matrix is R is then R plus 1 that is equal to that is 0. That means R is that is not equal to 0. R plus 1 that is the order of the R plus 1 that is equal to 0. Based upon these two, then we can define the rank of a matrix in briefly. For example, and next to further, and it is also denoted by the symbolical, it is a row of A. It is sometimes it is called as a row and it is denoted that is a rank of A. That is it is not a P, it is a row, it is called as a row. It is a denoted, this is the terminology. That is a row of A only condition. And based upon this one, next further we need to discuss methods. One is here echelon form of a matrix. And here what is the structure of the echelon form and what are the conditions for that echelon form it is required to satisfy. And based upon that, what is the structure of that matrix, then how to define the echelon form of a matrix. And after that confirmation that echelon form, then how to identify the rank of a matrix. That is also we need to understand properly. Here, whenever we need to set something, the matrix is satisfied the echelon form, here we need to satisfy some of the conditions, some of the following conditions. And what are the following conditions? Based upon this observation, this is the right side of the structure, we need to understand this is the rank of a matrix, this is the echelon form of a matrix. That means indirectly, sometimes based upon the matrix is after that applying the element row operations, we need to reduce it to upper triangular matrix. That indirectly in other terminology. That means based on under here one more we need to remember. According to under the echelon form of a matrix, we need to apply only the row operations only. The row operations only. Should not applying here, it is a column operations. That means under the echelon form of a matrix, we need to apply only that row operations. By applying the element row operations, we need to reduce it to like indirectly it is a echelon form that is a upper triangular matrix. This is the structure we need to understand, remember the condition. And regarding all these methods like that, we briefly discuss in that each and every like method given the like previous lectures clarity and clearly we discuss the number of problems in the like echelon form, rank of a matrix and all the methods we discuss properly in each and every lectures. Here, first of all, a matrix is said to be in echelon form. Here, a matrix is said to be in echelon form. What are the conditions? That means if it is satisfied some of the following conditions. What are the conditions? Here, based upon that after applying the element row operations, here, if 0 rows, that means by applying any row operations, if it is occur any 0 rows, then we put in the last row. That is a one fundamental conditions. Based upon this observation in the right side picture, here 0 rows is available. After applying this is the element row operations. I kept in the bottom. For example, if it is there is no 0 rows, not possible, then you forget about the conditions. But in case by applying any row operations, if we get any 0 rows, we put in the bottom. That is a fundamental basic concept. And second one, the first non-zero entry in each non-zero row is equal to either 1 or any unity. That means here this is the first non-zero row, 0 row I kept in the bottom. And rest of the 3 rows, and again here, while we are going to observing here, the first non-zero row. The first non-zero element is it is 1 and it is 1 and it is 1. The first non-zero element should be it is a 1 or either any unity. Either it may be 1 or something it is a 2 or something it is a 3 or it is a minus 3, whatever it may be. That means if 0 rows occur, we put in the bottom. We kept in the bottom. If it is a non-zero rows, first non-zero element should be either the 1 or unity. That is we need to understand. And third condition here, the number of zeros before the non-zero number, it may be in the top to bottom. It is top to bottom. It is before the non-zero number is a increasing level, or bottom to top. It is top to bottom. It is a increasing level, and bottom to top is a decreasing level. What is the meaning of this one? It is for example, while we are going to observing, these are the first, second, and third non-zero rows. Here, before that, for example, it is a 3 value. For example, that before the 3 number, it is a number of zeros are 2. And here, before the number, it is a 2 or whatever it may be 1. That before the non-zero number, the zeros are 1. And here, before the non-zero number, it is 1 or something, any non-zero number. It is, but in this problem, it is a example. It is there is no zero rows. That means here, but top to bottom to top, it is a decreasing level, and top to bottom it is a increasing level. Here, these are the three conditions. Sometimes it is a second option. Second condition, it is a optional. It is not compulsory, not mandatory. We need to remember these are the three conditions. One is by applying any on that given any matrix, by applying any row operations. If we get 0 rows, we put in the bottom. And first non-zero element should be either 1 or unity. Comparison between that, 1 to other row, it is a before the non-zero number, the 0 rows are clearly satisfied that top to bottom it is a increasing level, and bottom to top it is a decreasing level. These are the three conditions are required to satisfy. Then only the matrix is said to be echelon form of a matrix, and indirectly based upon this matrix is clearly it is a upper triangular matrix are also. That we need to understand like that. And based upon this one, here it is echelon form of matrix. And here based upon this one, here the rank, how to identify the rank. Based upon this confirmation that echelon form, the number of non-zero rows in the echelon form. And in this example, the right side, the number of non-zero rows are here. It is a 3. Therefore, the rank of a matrix is the 3. That is the meaning of it is based upon that we need to understand. According to based upon the confirmation echelon form, the rank of a matrix is equal to the number of non-zero rows in the echelon form of a matrix is called as a rank. And here we need to understand this is the structure of the echelon form. And next one, we need to understand what is a normal form. And sometimes it is normal form is also called as a canonical form of a matrix. And here also we need to understand what is the structure of the canonical form. Here, what are the conditions are required, and again what we are going to applying the under this the canonical form. Whereas in the echelon form we applied only row operations, but here under this canonical or normal form, here not only row including the column. That means by means of that is every non-zero matrix, that is M cross N matrix, can be reduced to the form that is IR 00 is called the normal form or canonical form with the help of elementary transformations, that is under the row and column operations. That means any matrix is given, we are going to apply including the row and column operations. Not particularly like row echelon form, it is a row and column operations we need to apply. Then we reduce it to structure is that is IR 000. And what is the meaning of here IR? That IR is nothing but that is unit matrix of order is a rank, that is a R. That means where IR is a unit matrix of order R. And here what is the meaning of R? R is a rank of the matrix. R is a rank of the matrix. And not only this is the one type of the normal form. And again, some other methods are also there. That is other standard forms. That is here the following matrices are also known as a normal form or canonical form of the matrix. That means not only particularly this is the one structure of the IR00. Either it may be in the form of IR, IR00 and IR0, IR00. These are some structures of the normal form or canonical form. By applying the row and column operations on the given matrices, we reduce it to these are the structures. Any one of the matrices should be satisfied. And IR is nothing but that is unit matrix of order R, and R is a rank of the matrix. And while we are going to observe in this one, it is I3, that means rank is 3, and it is structure of the second one, I30, and it is the structure of the third example, that is I30, and again the fourth example, it is a IR00. These are the structures of the normal form with suitable example for the normal and also the canonical form. We need to remember that mainly here, whereas in the echelon form, only applying the row operations, under the canonical or normal form by applying the row and column operations. Based upon these are the echelon form and normal form, we need to find the rank of the matrix. And further, we need to discuss the inverse of the non-singular matrices, that is inverse of the matrix by Gauss-Jordan method. Gauss-Jordan method. And here, under the Gauss-Jordan method, we need to apply only the row operations only. Should not applying any column operations, only the row operations. And here, how to find the solutions? How to find the inverse of the matrix by using the Gauss-Jordan method? What are the conditions? What is the structure? When it is applicable? What is the working rule like that? We need to observe here. First of all, in generally, the inverse is nothing but it is in urgent of a data. That is in general method to find the inverse of the matrices urgent of a data. But here we need to find the Gauss-Jordan method. Here, how to find the Gauss-Jordan method? Here, first find that what is the data of the matrix. Any matrix, first we need to find the data of a matrix. And data, after calculating this, find the data A if it is equal to 0 and not equal to 0. That means the two cases occur. The data is equal to 0 and data is not equal to 0. And if it is data is equal to 0, the inverse does not exist because of the singular matrix. The inverse, it is a data is 0, it is a not equal to 0 means that is a not applicable. And when it is applicable, then it is data is not equal to 0, it is inverse exists because of it is a data is not equal to 0 means that is a non-singular matrices, therefore inverse existed. And here if it is inverse existed, then how to find the solutions? That means first of all we need to consider in the form of matrix A and also A. That means it is a augmented matrix. Based upon this augmented matrix, A is the given matrix, I is the corresponding order of the unit matrix. This is a consider according to the matrix, and sometimes it is also considered A is equal to In into that is a A also. That is no problem. Both are according to that methods we need to follow that. And based upon this one, by applying the row operations, we need to reduce it to echelon form. As we know that how to reduce it to echelon form, only applying the elementary operations, we need to reduce it that A matrix is reduced to I and I is reduced to B. That means by applying the row operations, A is reduced to I and I is reduced to that is a B. And here B is called that is a inverse of the matrix. This is the clear procedure for that finding the Gauss-Jordan method to find the inverse of the matrix. But we need to remember only that is a row operations only we need to apply that. And what is the next one? And after that, it is a working rule clearly. Inverse of a non-singular matrices. Inverse of a non-singular matrix by Gauss-Jordan method. According to that preview, that is the inverse of a matrix. AB is equal to I is equal to BA. That is the definition of the inverse of a matrix. And here B is equal to A inverse. And find that consider according to AB in a non-singular matrix. Because that is the meaning of the data of A is not equal to 0. That should be satisfied. The steps 1, write A is equal to as A. Otherwise, that is a and I is also that is indirectly both are considered the same. And again applying the elementary operations, that is it is elementary row operations, then the matrix is reduced to it is A is reduced to I and again I is reduced to that is a inverse or something, it is a B inverse or B whatever it may be, that is a matrix. That is a matrix clearly reduced to B, then find the inverse of the matrix. And next one, according to the second one, that is a non-homogeneous system of linear equations. Under this is the module 1, that is a part B like that. The part A is finding that only the rank and again the normal for the rank and inverse of the matrices. And part B is under the system of linear equations, under the non-homogeneous equation and homogeneous equations. And we need to briefly explain about that all these things. And the previous lectures are also we discussed clearly that individually the topic wise we discussed that clear videos. Here, first of all, we need to write in that x is equal to b, and here that non-homogeneous equation is nothing but it is b is not equal to 0. And under here, if it is a consistent and also inconsistent, and again here, what is a consistent? That means rank A is equal to rank AB. And again here, inconsistent is nothing but rank A is not equal to rank AB. And the meaning of consistent is nothing but it is having the two conditions. It is a unique solutions and also the infinite solutions. And again the inconsistent is nothing but there is no solutions. It is under here, it is no solutions. That is the meaning of here. And again the unique solution is nothing but only one solutions. The condition is satisfied, rank A is equal to rank AB is equal to n. And again infinite is nothing but rank A is equal to rank AB is less than n is the conditions. And here that n is nothing but the number of variables. That means in that given equations here, that is x comma y comma z, for example, these are the number of variables. It is not equations. That n is nothing but number of variables. That means by using the given equations, we need to write according to the procedures of the augmented matrix and echelon form, and again find the solutions based upon that rank A, B, and n. We need to identify this is the conditions for that consistent unique solution and infinite solution, and also the no solutions under the consistent and also inconsistent the conditions. These are the clear information for that non-homogeneous equations. And next one, what is the homogeneous system? The homogeneous system is nothing but it is clearly, whereas observing here, it is a b is equal to 0. B is equal to 0. That means there is no constant terms. The type of the equations are called as a homogeneous equations. And under here, again we need to write in the augmented matrix and again find the solutions. It is all the homogeneous equations are always it is a consistent, and the consistent is nothing but it is having the solutions. It is rank A is equal to rank AB, and here based upon this one it is a trivial and also the non-trivial. That means it is a unique solution and also it is a infinite solutions. It is a infinite solution is nothing but it is a non-trivial solutions. Non-trivial solutions. And what is the meaning for that? Rank A is equal to rank AB, and here also B is nothing but it is a 0. And what is the infinite solution? Rank A is equal to rank AB is less than n. And here we need to remember that B is equal to nothing but it is a 0 is the conditions. Because of there is no, but we need to understand this the concept. And again here also n is nothing but the number of variables. Here also, for example, x comma y comma z, that is nothing but that is a number of 3 variables are the conditions, not any equations. And again based upon this non-homogeneous equation and homogeneous equation, like a preview of the total conditions, the linear equations, it is one by one is a non-homogeneous system, and again it is a homogeneous system. And here clearly in the previous slide clearly we shown individually, but here it is together the conditions. It is a consistent, and next is a inconsistent, and next one is it is a unique trivial, and again other one is a non-trivial solutions. Under the consistent, again the two topics, one is a unique solutions, that is a number of unknowns, and again it is a number of unknowns. That means it is a is equal to n and it is equal to less than n. And again it is a meaning of it is a unique solution, and otherwise it is a infinite many solutions. And these are the clearly we need to understand based upon this flow chart here how to identify under the system of linear equation like the non-homogeneous equation and also homogeneous equations procedure. If you remember all these conditions, we need to discuss that clearly easy to understand, and again that is a question bank based upon the module 1. Here that is according to the consistent. These are the we need to remember. Already previously we shown that clearly flow chart also. Based upon the flow chart, we need to find the solutions. While we are going to discuss these are the system of linear equations are like part 1. These are the non-homogeneous equation, and this slide is a homogeneous equations based upon the trivial and also non-trivial solution. And we need to remember the trivial is nothing but it is not equal to 0, and moreover it is all the solutions are 0, A non-trivial solution is that data is equal to 0. It is a infinite number of solutions. That we need to understand that data is not equal to 0, that is a trivial. Data is equal to 0, that is a non-trivial. And there itself, that is a unique solution, all the values are 0, and it is infinite number of solutions. Yeah, for example, now we'll go to discuss that clearly. Our topic is that is a model 1, that is a question bank. Under here, we are going to develop like the three parts, part A and part B and part C. Under the part A, like some 10 questions are available, and again part B like 20, and again part C is also 20. We need to discuss the part A, that is under the critical thinking questions. We need to discuss regarding that based upon the totally what we discussed that clearly under this is the model 1, that is a matrices. Here it is a critical thinking. That means we need to understand that logically. Find the conditions on A, comma B, comma C. Find the conditions on A, comma B, comma C so that the equations have a solutions. Somebody are like thinking it is a problem is something is incomplete like that, but it is clearly given the problem is having the solutions. The having the solution means we need to understand properly. The equations are clearly it is a non-homogeneous equations. Under the non-homogeneous equation, the problem is given it is having the solution is nothing but the condition we need to remember. The equations are having solution is nothing but if and only if it is a consistent. That means the equations are consistent. That means indirectly it is having the solutions. Okay. Therefore, based upon the condition of rank A is equal to that is a rank of AB, then that is the meaning of the equations are consistent. That means based upon this one, first of all, we need to write in the non-homogeneous equation pattern, we need to write what is the rank A and rank AB. And based upon that, we need to equate that rank A is equal to rank AB. Because of the equations are given only indirectly, it is a critically like logically, it is a consistent. That is having the solution is nothing but it may be that is a consistent. That based upon that, it is rank A is equal to rank AB. And after that, given equations, we need to write in the what is a matrix A and again what is a matrix B. We need to reduce it to like the echelon form, whatever it may be. And after getting this one, by equating the condition finally, then find the solution with the help of that is a rank A is equal to rank AB. Then we get the combination of like A comma B comma C, we get the that is sufficient solution of that condition here. And next one, for what values of A comma B, the following equations are having the unique and infinite and also the no solutions. Here also the problem is asking for what is the values of A comma B comma C. And given the condition is, it is a unique solution and infinite and also no solution. That means here, first of all, the equations we can consider under the augmented matrix, and we reduce it to like that echelon form like that. And again after that confirmation here, the unique solutions. The unique is nothing but as we know that according to under the non-homogeneous equation, it is a system of equations are consistent. That is rank of A is equal to rank of AB and again is equal to n. And here n is nothing but x comma y comma z. That is a three values. Based upon the reduced to echelon form, we need to equate that rank A is equal to rank AB is equal to n. And again, that is the meaning of our unique solution and find the values are here A comma B comma C. When it is satisfied, that we need to after confirmation of the echelon form, we get the solutions. And again, similarly, that second one, it is a infinite. Infinite is nothing but it is a rank of A, and again it is rank of AB, and it is a less than A. And again here also after that reduced to echelon form from the given equations under the like non-homogeneous equation pattern, then we need to equate that rank A is equal to rank AB is less than n. As we know that here also n is a condition that is a 3, and based upon that less than is equal to also satisfied and is equal to condition is also satisfied. And again based upon this one, it is a condition the infinite solutions are satisfied. And again coming to point that is a no solution. No solution is nothing but here also based upon this echelon form, it is a confirmation. And again, we need to find out that is rank of A is not equal to rank of AB. Based upon this condition, we can define that the function, the equations are the no solutions. That means entirely in this non-homogeneous equation, we need to write in the augmented matrix and reduce it to echelon form by using the row operations. And again, find with the help of these are the three conditions we can explain when it is equations are like A comma B comma C, the equations are the unique and infinite and also no solutions. And again next one, calculate the rank of the matrix echelon form, that it is a echelon form. Under the echelon form, here we need to applying only row operations, should not applying any column operations. And again, as we know that echelon form is nothing but according to given that it is a upper triangular matrix like that. That means the condition first one, if it is a satisfied, like any row operations we should put in the bottom. Second condition, it is a first non-zero element should be either any one or any non-zero number. And the third condition, before the non-zero number it should be, that is a bottom to top, it is a decreasing order. Bottom to top it is a decreasing order. Therefore, based upon this one, you can find out it is a number of, after that confirmation, the number of non-zero rows is equal to the rank of a matrix. Based upon the echelon form, we need to reduce it to echelon form. Therefore, these are the three problems based upon under the critical thinking. And for the next one, it is the fourth one. Find the inverse of the matrix by using the Gauss-Jordan method. Here, it is also Gauss-Jordan method. That means only according to either A is equal to, that is, it is a given matrix is I3A, or it is nothing but A and again I. Meanwhile, by applying the row operations, we need to reduce it to the matrix is I and again A, it is a B. Here, since B is nothing but inverse of the matrix. It is also clearly the data of A is not equal to 0. That is, the condition is required. Based upon these operations, and again by applying according these are the operations, we need to find the solution. We obtain whatever that invariance of A is equal, that is I. That is I is equal to A inverse, that is the inverse of the matrix. The matrix is reduced to I is equal to A to I. Again I is reduced to, that is the inverse of the matrix. And find the rank of a matrix by echelon form. And here also the echelon form is nothing but by applying only the row operations, and again here also find out what it is here. The condition matrix is reduced to, that is a upper triangular matrix indirectly. And again the first condition, zero rows condition, and again third condition, whatever it may be, that depend upon that. If we are able to get, we need to follow that. One is a zero rows available bit in the bottom. The non-zero element should be first element is a unique or any value. And the third condition, bottom to top, it is a before the non-zero number, it is a decreasing order. And here also the rank is nothing but the number of non-zero rows is equal to the rank of a matrix. Whatever it may be, obtain that. Based upon this one, we need to find the solutions. And again the next one, find the, by reduce it to normal form and find its rank. The normal form is nothing but from the given matrix we need to apply row and also the column. Not only row, it is row and column operations. The matrix is reduced to like any one of the form, that is IR00 or IR0 or IR0 and again IR. Whatever it may be, any one of the form it will be available. That depend upon that. Here, that is a, here R is a rank of a matrix. And here IR is nothing but that is a unit matrix of order R. This is the procedure to find out that is a normal form. And again based upon this one, we need to find the solutions. Next one, solving the system of linear equations. It is a, here while we are going to observing this problem, it is clearly it is a homogeneous because of there is no constant terms. And here solve, that means while we are going to observing here, we need to find out according to either any condition that depend upon the, it is a rank of dta is equal to 0 or dta is not equal to 0. We need to find out solutions. We need to reduce, otherwise that is a and also 0, then you find out what is the conditions. And again based upon this one, it is a rank of a is equal to n. It is a unique, and rank of a is less than n. It is a infinite solutions. And based upon that, you need to find the solutions. That is the meaning of conditions. Next one, find the inverse of the matrix by using the Gauss-Jordan. This is also in the previous example like that. It is considered the data of a is equal to not equal to 0, first one. And again that a or something, it is a I, other way, which implies it is a and I, and also sorry, it is also that I, and again it is a B. since P is nothing but A inverse of the matrix. Here only the row operations. And again here it is from A to I, and again I to it is also B is a matrix. And next one, from the following matrix find the normal form. The normal form is also nothing but it is by using the row and also the column operations. We need to apply any one of the form, that is IR or IR00, IR0, and again IR0, like any one of the form we get by using the row and column operations. We reduce it to matrix. Here these are the some problems based upon critical, and examine the consistency of the system of the equations are consistent. And again here also they are asking to find out it is a find out what is a augmented matrix, and by using the echelon form, reduce it to echelon form. Find out consistent is nothing but given that rank A is equal to rank of AB, and again based upon that you need to find the solutions. Either it may be is equal to n is a unique and less than n is a infinite solutions. Based upon these are the conditions, we need to find the solutions. This is under the critical thinking problems. These are the 10 problems which is covered based upon every method we discuss. And before going to discuss these are like problems, we need to understand what we discuss before this question bank. What we discuss, that is a briefly explanation of all the methods that we need to remember particularly. And again next further here part B, that is a long answer questions. Here also how to find the solutions. For what values of A comma B, the equations have the unique and infinitely unique solution. That means here also the equations you can write according to augmented matrix. We need to reduce it to echelon form. And again based upon this one, it is a rank of A. Unique means it is a for unique solutions. Here based upon this condition, rank unique, rank of A, rank of AB, and is equal to n. And here infinite, the solutions is less than n, and no solutions. We need comparison, rank of A is not equal to rank of AB. That is the meaning of unique and infinite and also no solutions. When it is the conditions are A comma B, such that the conditions. Find for what values of A comma B based upon these are the three conditions, we need to find the solutions. And second one, solve the system of equations. And solve the system of equations is nothing but the same the conditions of follow. Next third one, by reduce the matrix into normal form. The normal form is nothing but here also the matrix is row and that is a column operations. As per like according to the previous the 10th problem like that, it is row and column operations. We need to reduce it to IR00 or IR, and again IR0, and again here IR000. Like any one of the standard form, you obtain that matrix, and again here the RAR is nothing but it is a rank of a matrix. Based upon that, we need to reduce. Next, determine A comma B such that the rank of a matrix is 3. Here, determine the rank of a matrix. A comma B, rank is 3. That means the data of A is equal to rank is 3 means the data of A is not equal to 0. Based upon this one, we need to find out. Otherwise, here the matrix is reduced to by row operations. By row operations, here reduced to like echelon form. The 3 non-zero rows is required. 3 non-zero rows required. That means we need to reduce here 0 and here 0 and here find out what is the value of this one. Based upon it is a like it is a 3 non-zero means it is a conditions are that A comma B is also not equal to 0. That condition is required to satisfy. Next, for what values of A comma B, the equations are here also the same. The first problem, it is a for unique solutions. It is a rank of A is equal to rank of AB and is equal to n, and less than n is a infinite solutions. No solution is nothing but rank of A is not equal to rank of AB. And these are the like problems we need to discuss clearly. And determine the value of K such that the rank of a matrix is 3. And here also the order of the matrix is the 4 by 4, but the rank is given the 3. That means the data of 4 by 4 is equal to 0. Since given rank is equal to 3. The rank is 3 means automatically by using the row operations, we need to reduce it to the data is equal to either the 0, otherwise that given the rank is a 3 conditions. That means 3 number of non-zero rows is also satisfied. Or echelon form, we need to find the solution. And next one, find the rank of the matrix by reducing to echelon form. Normal form means here also the row and it is a column operations, including these two. Here the matrix means either the IR and again IR0, otherwise IR0 and again IR000, like any one of the form. And here also the rank is nothing but it is a rank of a matrix. The depend upon the matrix, we reduce it to like that row and column operations. We need to reduce it to unit type of the matrix. And unit type of the matrix is nothing but here depend on, for example, I4 that is a rank is 4. I3 means it is a rank is 3. I2 is nothing but that a rank is 2. And any one of the form we obtain that according to either any one of the form we get the solutions. The depend upon that we need to find the solutions. And further it is find the real value of lambda. The system of equations are non-trivial. And first of all, the equations are not in the standard mode. That is x minus lambda x plus 2y plus 3z is equal to 0. And 3x plus y minus lambda y plus 2z is equal to 0. And 2x plus 3y plus z minus lambda z is equal to 0. That means based upon this one, 1 minus lambda 2, 3 and 3, 1 minus lambda 2 and again 2, 3, 1 minus lambda. And we need to find out the dative. It is having the non-trivial solution. Non-trivial solution is nothing but automatically which is date is equal to 0 because of since given that non-trivial. According to the definition of this one, it is a non-trivial is nothing but it is a date of A is equal to 0. That is a non-trivial. And based upon that, you need to find out what is a lambda value. By equating the date value, you find the solutions. Next, find the inverse of the matrix by Gauss. And here also find the date A is not equal to 0. And again, it is a and also I. Then find out it is a I2, that is a B, since B is equal to the inverse of the matrix. That is by applying the given matrix A is reduced to I and again I is reduced to A. That is row operations only. We need to apply row operations. And second one, what is the inverse of the matrix? It is also same like that. Indirectly, it is a row operation is nothing but Gauss-Jordan method. That means it is also same the conditions, same the method working. Next one, for what values of A, the equations have this unique solution will have the solutions and solve them for what? Having the solutions. Having the solution is nothing but it is a condition is the equations of rank of A is equal to rank of AB because of the equations having the solutions. And based upon that, you need to find the solutions according to by using the echelon form, then find the solutions. That is a row operations, we need to reduce it to echelon form. Echelon form, we will find the solutions. Next, find the rank of a matrix by reducing to echelon form, and it is also nothing but echelon form is nothing but that is a row operations. We need to apply the matrices, upper triangular matrix, then find the solutions. It is the first condition and second condition and also the third condition. And next to 13th one, the for what values of lambda the equations are. Here also the equations are given that clearly it is a homogeneous equation. As per the homogeneous equation, it is a non-trivial solution is given. That non-trivial solution is nothing but it is a dA is equal to 0. That means we need to find out according to by using that lambda minus 1, 3 lambda plus 1 and 2 lambda and lambda minus 1 and 4 lambda minus 2 and lambda plus 3 and 2, 3 lambda plus 1 and 3 into lambda minus 1 is a value. We need that equal to 0. Find the value of lambda values. This is the according to the non-trivial solution. Whenever the equations are under the homogeneous equation, non-trivial is nothing but data is equal to 0. Therefore, we need to find the solutions. Next, to find the rank of the matrix by reducing to echelon form. That is also echelon form is nothing but same based upon these are the conditions we need to find the solution. That means the 12th one and also the 13th one, 12th and the 14th one both are same. We need to find the reduce to by applying the row operations. We find the solutions. Next, to reduce the matrix into normal form, it is also like row and also the column operations. By using the row and column operations, we need to reduce like IR and IR 0 and again IR 0 and also IR 0 0 0. And here also where that R is a rank of a matrix. These are the methods already basically. Find the inverse of the matrix by using the elementary operation. That is nothing but, it is also nothing but Gauss-Jordan method. Gauss-Jordan method by applying the row operations, that is A and I. The matrix is reduced to I and A. That means A to I and again I to, that is B is the matrix. Where since B is nothing but inverse of the matrix condition. And here also we need to require to satisfy that A is not equal to 0. That is important to remember the condition. And next one, for what values of A, the equations are the may be consistent and if and only possible the solution. The equations are consistent. The consistent is nothing but the rank of A is equal to rank of AB. Based upon this one, we need to find the solutions. Based upon that is the matrix is reduced to, that is I A to B is reduced to that echelon form. We need to find out that is the conditions. That is the first condition, second condition, and also third conditions. And after that, you solve the equation that means x comma y comma z also you need to find the solutions. That is depend upon either the rank is equal to rank is condition, and again after comparison that you need to find the solutions. Next, it is the echelon form. Echelon form is nothing but row operations only. The matrix is reduced to upper triangular matrix, first condition, second condition, third condition. And based upon that here, the number of non-zero rows is equal to the rank of a matrix. Same, the next one also, this is also the same conditions. The 18th one and 19th one both are same. Solve the system of equations. It is also nothing but, solve the system of equations is nothing but, you find out the rate of A is equal to, what is the value? Otherwise, we need to reduce it to, that is homogeneous equation, find the solutions. That these are the conditions we need to check it. And again, part C, under the part C, it is only the short answer questions, whatever we discussed that briefly, all the concepts, and again the question bank like the critical thinking and question bank like etc. These are the some 20 problems are based upon the short questions. Write about the consistent. The consistent is nothing but according to the equations are like I having the solution, that is rank of A, it is rank of A. Again in that it is equal to n and also less than n. The equations are having the solutions. Having solutions. Having solution is nothing but either the rank A is equal to rank B if and only if the conditions. If and only if the conditions. Rank A is equal to rank B is equal to n is a unique and n less than n is the infinite solutions. It is a unique and it is a infinite solutions. And state inconsistent constitution. That means according to this one, it is a rank of A is not equal to rank of AB. That means it is a no solutions. No solution. Trivial solution. And these are under the homogeneous equations. Homogeneous equations. Under the homogeneous equation, all the system of trivial solution is nothing but it is a delta A is not equal to 0. Delta A is not equal to 0. That means x1 is equal to x2 is equal to x3 is equal to that all the values which is 0 values. That is unique solutions. Unique solution. What is the meaning of the non-trivial? The other than this one is nothing but homogeneous is same, the condition, but delta A is equal to 0. But here it is a infinite solutions. Infinite solution. And define about non-homogeneous equation. Non-homogeneous equation is nothing but under the Ax is equal to B, and again here B is not equal to 0. That is the meaning of non-homogeneous system of linear equations, having any one of the constant values which is occur. And write about the rank of a matrix, that is according to shortly. And shortly it is a three conditions. It is a maximum number of linearly independent. It is highest order of non-zero. It is greatest largest order of any non-vanishing of a matrix. And again it is denoted. It is a rank of A only. And briefly, if it is saying the R, the data of the data of r plus 1, it is a 0. That is the condition. Until the data of r is not equal to 0, it is a rank. And again, data of r plus 1, the data of r plus 1 order is a 0. That is together. Explain elementary operations. Elementary operations are nothing but row and column operations. One is under the row, one is Rij, Ri of alpha, Ri plus alpha into Rj. And similarly, column operations are also similarly column operations. These are under the row operation. Explain about the rank of a matrix in briefly. Briefly is nothing but the data of R is not equal to 0, and then data of R plus 1, it is equal to 0. The data of the matrix. State about the two properties of rank. State about the two properties of rank of a matrix means about the two properties. It is also like based upon these are the two properties we can define that. Properties like that, no problem. Write about the conditions of a normal form. Conditions means by applying the row and also the column. Finally, the matrix is reduced to that is IR, IR0, and IR0, and also IR000. These are the normal form where that is R is a rank and IR is the unit matrix order R. Solve the system of equations. That means we need to find out according to either the AX that is 0 is equal to find out. Otherwise, it is a data of A. We need to find out is equal to 0 or not equal to 0. We need to find the solutions. Solve the system of equations here also. Same, the equations we can write that A and also 0. We can find out the data of A and data of A. Explain the Gauss-Jordan working rule. Gauss-Jordan working rule is nothing but the matrix is the row operations must ensure the data of A is not equal to 0. The data of A, and again which is equal to the row operations, the matrix is reduced to B is a matrix, since B is the inverse of the matrix. That means A is a matrix is I and I is reduced to B. Explain about the system of linear equations. That means it is a under the system of linear equation in nothing but B is not equal to 0. That is equation Ax is equal to B and B is not equal to 0 non-homogeneous and B is equal to 0, it is homogeneous equations. This is the non-homogeneous equation and this is the homogeneous equations. Find the rank of a matrix based upon that either the row or column or row and column. We need to reduce echelon or normal form. Find that based upon that either the echelon or something whatever it may be, find that. Calculate the value of cases that the rank is 3. That means given that rank is equal to 3, that means order of the matrix is also 3, that it is the data of 3 by 3 is not equal to 0. Then we get the value of find the value. That means here calculate means the matrix is the order is a 3 by 3, then given the rank is also 3, then automatically the data is not equal to 0. That is the meaning of to finding the solutions. Find the value of k such that the rank is 2. That means given rank is 2, the order of the matrix is 3 by 3, that is the data of 3 by 3 is equal to 0. You find the value of k is a value. For what values of k, the rank is 3. Given rank is 3, the matrix is order is 3 by 3, then find that data of 3 by 3 is not equal to 0. Then we obtain that value of k. And here also that if we, while we are going to observing this matrix, it is a 4 by 4, but it is a like r1 minus r1 divided by 4, and again r2 minus r1, and again r3 minus r2 2r2, and again r4 minus 9r2. The finally matrix is reduced to 1 0 0 1, sorry, it is 1 1 1 1 and 0 0 0 and 0 0 0 0 and 0 0. Therefore it is a rank of A is the matrix is 1 is the value, because of the number of non-zeros are, it is a 1 non-zero number. Find the rank of a matrix here also. The matrix is the upper triangular matrix, upper triangular matrix, upper triangular rank of A is equal to 3, and R the data of 3 by 3, the data of 3 by 3 is also not equal to 0. Therefore it is also to find the solutions. These are the some of the like short questions, and again first part is the critical thinking, and part B is the essay type questions, and part C is the short type questions. And based upon the before question bank, if we thorough that description about all the like concepts we need to remember, then only easy to survive. Okay, I hope everybody understood properly. These are the model 1 like matrices, that is part E and part B and part C. Okay, wish you all the best and thank you. And again, in the next session, we discuss that matrix like module 2, that is a question bank under the matrices and calculus. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.